Hi there, this is electric fields number 5. This is an electron passing through parallel plates synoptic question. So these can be quite laborious, lengthy, and worth a lot of marks, so it's probably important that we go through this. So what I'm going to do is give you the question. So here it is. If you want to pause it, have a go at it, and then I'll take you through each of the 6 sections after you've had a go. So on the left hand side we've got a parallel plate, and an electron is projected into the evacuated space between the 2 charged plates of length 5 centimeters, as shown in the diagram. And the electric field strength is given, and the velocity of the electron is 3.2 times 10 to the 7 meters per second. So it's just going to pass through, and it's an electron, so it's going to come upwards in something like that. Part A then. What is the size and direction of the electric force on the electron? So we know that electric field strength is force over charge. So the force would be EQ. So we just need to do the electric field strength, which is 3.5 times 10 to the power 4 times the charge of an electron, which we should know is 1.6 times 10 to the minus 19 coulombs, which gives a force of 5.6, so 5.6 times 10 to the power minus 15 newtons. Hopefully that's okay. So let's have a look at the next bit. So that's part A. So part B. What is the horizontal velocity of the electron as it leaves the plates? Well, this is pretty straightforward. The initial horizontal velocity is 3.2 times 10 to the 7. And there is nothing slowing or speeding this electron up in the horizontal direction. It's all vertical. So the answer to B is quite simply the same. It won't have changed. So let's have a look at C. So how long does it take to pass between the plates? So we've got velocity is distance over time. It's constant velocity, so the 3.2 times 10 to the 7. So we can simply do time is equal to distance divided by the speed. So the distance is 5 centimeters, which is 0.05 meters, divided by the velocity, the 3.2 times 10 to the 7, which gives a time of 1.56 times 10 to the minus 9 seconds. Or 1.56 nanoseconds. So let's move on to the next part D. So part D, what is the vertical acceleration of the electron? So the vertical acceleration is where the force is occurring vertically. And the force we figured out in part A, the 5.6 times 10 to the minus 15. So the acceleration is simply force divided by the mass, Newton's second law. So that's 5.6 times 10 to the minus 15 divided by the mass of the electron, which is, we should know, is 9.11 times 10 to the power minus 31. And that gives us an acceleration of 6.15 times 10 to the power 15 meters per second squared. Hopefully part D went okay. Let's have a look at part E then. Remember to pause and rewind whenever you need to. So part E, vertical velocity. So I'm just going to write suvat. So S, not interested. The initial speed vertically is 0 meters per second. The final speed V is what we're looking for. The acceleration is the 6.15 times 10 to the 15. And the time is the time that it's travelling vertically is the time that it's travelling horizontally for. This is from the basics of projectile motion. So that's the 1.56 nanoseconds, so 1.56 times 10 to the minus 9. So we're just going to use V equals U plus AT, and U is 0. So it's just V equals AT. So the acceleration is a 6.15 times 10 to the power 15, multiplied by the time, the 1.56. It's times 10 to the minus 9. I'll just write nanoseconds just because I've run out of room. And if you put them in your calculator, it'll give you a velocity of 9.594 times 10 to the 6 meters per second. Hopefully that went okay. Right, let's finish off then. Part F, size and direction of the final velocity. So this is a bit of trigonometry. So we want the hypotenuse, and we've got the two components. We've got the vertical and the horizontal. So the horizontal is the 3.2 times 10 to the 7 meters per second. And the vertical is what we just found out. The 9.594. I'm just going to write it up here. 9.594 times 10 to the 6. So we just need to do Pythagoras. So to get the hypotenuse, we need to square these and add them together. So we've got the 3.2 times 10 to the power 7 squared plus the 9.594 times 10 to the 6 squared, and then square root the answer. So that will give us a resultant velocity of 3.34 times 10 to the 7 meters per second. Hopefully that's gone okay. And then finally it wants a direction, so we're going to need to calculate the angle. So I'm just going to make some room. So once again we've got, that's the 3.2 times 10 to the 7, and we've got the 9.594 times 10 to the 6. So to get we need the angle theta. So we've got the opposite and the adjacent, so that's tan. So it's tan theta is equal to opposite over adjacent. So theta is going to be the inverse tan O over A. So I'm just going to see if I can write this out. So opposite is the 9.594 times 10 to the 6 divided by the adjacent, the 3.2 times 10 to the 7. And if you put that in your calculator, you'll get an angle of 16.7 degrees from the horizontal. Hopefully that example has gone okay. If you want to do it again, please feel free to have a look again. Thanks for watching. I'll speak to you soon.